Hello, testing, testing. Hello. Bam. I'm here. Okay, we're doing some more recursion today. So, to summarize what's going on, I've been doing the blind 75 Leetcode questions. It feels like we've been here forever, the dynamic programming. I think we finished Househopper 2 last time. Yeah, I feel like it's been here forever too, because halfway through, we switched from Java to Python, right? And then we started over, and then now we're back here. Okay, so today's problem is decode ways. I might do another one if I have time. Also, I just realized I forgot to sign in. Give me one moment. One moment so I don't accidentally reveal my real name in the username or the email. There we go. Now we're back. Switch this to dark and then Python. Sick. Okay. Decode ways. You have intercepted a secret message encoded as a string of numbers. The message is decoded via the following mappings: 1 to A, 2 to B, 25 to Y, and 26 to Z, and everything in between. However, while decoding the message, you realize that there are many different ways you can decode the message, because some codes are contained in other codes, 2 and 5 versus 25. For example, 1106 can be decoded into this and this because of different number groupings. Makes sense. The grouping 11106 is valid is invalid because 06 is not a valid code. I see, you can't begin with 0. Only 6 is valid. Note, there may be strings that are impossible to decode. Ooh. Given a string S containing only digits, return the number of ways to decode it. So, okay, our task is to return just the integer. We don't have to return literally what it can decode to. If the entire string cannot be decoded in any valid way, return 0. Answer fits in a 32-bit integer. I don't think that would affect us too much anyways. So, example 1, 12 can be decoded 2 ways. Makes sense. Okay, cool. So basically the problem is giving you a string, for example 12 like this, which contains a bunch of numbers. It's basically a number in a string representation. Assuming that, you know, letters A through Z are represented through numbers 1 through 26. Return the number that represents the number of ways you can decode this string of integers to a string of letters, basically. And I guess it's kind of tricky because, for example, 12 you can interpret as 1, 2, A, B, or just the entire number 12, which evaluates to L. So in that regard, it's kind of tricky. Example 2 here, 2, 2, 6. Output is 3, you could do 2, and then 26, 22, and then 6, or just 2, 2, and then 6. 06, 0. Okay, so we have to return 0 if it's invalid. 06 cannot be mapped to F because of the leading 0. 6 is different from 06. In this case, the string is not valid encoding, so return 0. Okay. Naruhodo. I think I want to approach this with recursion first. We have a really easy base case, right? I think we've seen if the first character is just 0, then that's completely invalid, right? There's no way you can... Yeah, 0 does not represent any single letter, and then you can't combine 0 with any number, so... I guess first equals 0, then you return 0. I feel like we should... We need to figure out a way to iterate through all the integers somehow. We might need two variables, one to track the start index and one to track the end index. You know, in case you want to... is that true? You know what? Sure, let's run with that idea. Let's say in our helper function here, we still take in string, but we also take in an I and then a J. Maybe I is the beginning index, J is the end index, and obviously I and J can only have like difference of 2. They have to be right next to each other. Actually, is it practical to do I and J? Can we just have an int that represents our last number that we're using, you know? You know what? Sure, let's run with this. Okay, so let's say we're at 1, right? Let's say we're at 1. What would be our recursive frames? Maybe we would do a s comma both I plus 1 and then a j plus 1. I guess we're assuming that we're assuming that we just take 1 as is, and then we increment both our start and end index. Or we can do s, the start index remains the same I, and then only j plus 1. Yeah, so we're saying we're keeping the previous one, and we're trying to make I guess, a digit between 10 and 20 now. I'm trying to think, is it practical to do an I and j? Or should we just have a variable that stores the last character that we used? I'm starting to think it seems kind of overkill to store 2 ints like this. Maybe we'll do a you know what? I think it's fine. Let's run with this for now. I was gonna say we can either store an integer that represents the previous int, like 1 or 2, so on. But I think this works. Okay, so there's some caveats here, right? So this case, where we increment just the end index, ooh, this might be a bit more complicated, because what if we also need to make sure that the start index and end index are only right next to each other. You know what? I'm going to just do a one variable for storing what the previous character was. So f of s, the current index, and the previous one. Yeah, okay. Yeah, so for every integer in the string, we have two options. One is to just increment the current previous, increment the current number, assuming we use it as is, as a single digit, and then previous, or just do like nothing, right? No? Can we do like none? None. So this is the case where we just use that digit by itself. Then there's the case where s remains the same. We increment the digit, but we use the current digit as the previous number to append to. So si, yeah, okay, I think I like this better. This is a bit cleaner. Okay, so we have to be careful here. We can only do this if, under certain conditions, if the current digit is equal to 1 or 2, yeah? You can't have like number 36, 31, 32, etc. We only support integers 1 through 26. Also, we can only do this if, let's say we're doing let's say we're at, so the current example is like 11106. Can we only do this condition if we don't already have a previous digit? So let's say we're here. Previous digit. Does it make sense to put the current I? No, it doesn't, right? We can't put this 1 as the previous digit of the next one because it's already used an 11 here. So previous has to be equal to none here for this to work. Yeah, okay. Cool. We probably also have to do like a 1 plus here to represent the single digit that we're adding. Okay. What about this one? We haven't really figured out if our digit is valid or not, right? Oh, hold on. Should we figure out if our like double digit number is valid here and then add a number here to represent that? You know what? I think it's more convenient to do it here. 1 plus, yeah. So we'll have to check if the next element is like s of I plus 1 is equal to well, we'll have to check if the entire number is equal to between 1 and 26. So in this case, we'll do like I plus 2, yeah? Wait, we don't even need to store the previous then, if we're just checking off the bat. You know, if the next two are good, you know? So we can take out this previous here. No need to input none here. No need to input the next one here. Yeah, this seems right, no? And then in the end, you return the sum of these two. Okay. That feels good, no? What's the base case? If I is out of bounds, yeah, if I is out of bounds, then we return 0. That feels fine. Yeah, I think this works, no? Si, if first, wait, this base case is kind of irrelevant now, isn't it? Or actually, maybe this can be a base case. But then we'll have to do this check like every single time. Maybe we can do this like outside and this is like a whole nother helper function. So if I is out of bounds, return 0, 1 plus using the current digit as its own number, or if I and I plus 1 is equal to between 1 and 26, calculate this too, return the sum of these two. I feel like that's it. No? Okay, let's try implementing this then. And we can do some caching too, so it'll be a bit faster. Okay, let's go. So we're going to need a helper function, def helper, which takes in s, which is a string. Okay, so, right, we're going to need a, yeah, we need a helper function anyways, because we need to store an I, the current index, int. So if I is greater than or equal to length of s, then return 0, because then you can start adding stuff to it in your previous recursion frames. So give me one moment, I'm going to check on something real quick. Okay, sick. Okay, next, we can always use the current number as its own digit and then continue constructing the message. So 1 plus, let's do single digit is equal to 1 plus f of, or the helper, current string is the same, and then I plus 1, increment the current index. Okay, double digit. Let's default to 0 at first. So the combination of letters that we can make with using double digits is contingent on this condition, right? So if I plus 1 is in bounds, I plus 1 is less than length of s, and we probably don't even need to check if the current digit is 1 or 2, right? We can just extract the digit formed by I and I plus 1 immediately, right? And say, okay, is this a valid number between 1 and 26? So, should we store this in a variable first? Hello, hi, welcome to the stream. I cannot tell who's... Oh, Sal, hello. My chat is like, the contrast isn't enough for me to tell whose name it is. Hi Sal, how you doing? Do you Leetcode too? I plus 1 is less than length s, and okay, we have to extract out the double digit represented by I and I plus 1. D is equal to s dot substring. Is this how you do substrings in Python? I plus 2. Oh wait, we have to be careful that this is inbounds too. So if I plus 1 is inbounds, then we can probably do this. Let's do the number is equal to s dot substring I comma I plus 1 Python substring. Oh, this is how you do it. the end is not inclusive, right? Exclusive, right? Okay. I guess I'm thinking Java, so I plus 2. How do you convert a string to an integer? String to int. Oh, that's how you do it? Just int. Oh, nice. That's convenient. I like that. So if, does this notation work in Python? If 1 is less than or equal to n, less than or equal to 26, notation. Oh, you can, yeah, this does work in Python. You can do a chain comparison like this. I like this. So if the number extracted is between 1 and 26, then you can do double digit is equal to 1 plus helper s comma 1 plus 2. Yeah, okay. And then in the end, you return the number of combinations you can make with single digit plus double digit. Yeah. And then on the outside, you can do if s, if the first character of s is equal to like 0, then you just automatically return 0. That's an easy base case. Else you return helper, pass in the s, pass in 0. I just realized there might be some cases I'm missing here. What if everything is just 0? I mean, what if it's like 1 followed by a bunch of zeros? That wouldn't work, right? So give me 1 second, I'm going to turn on my fan. Do I actually have to extract the single digit too and make sure that's not 0? Maybe this is 0 by default. So if the current digit si is not equal to 0, then the best combinations, like the max combinations you can make using that single digit is equal to this. Otherwise, 1 through 9 should work, right? Think so. Yeah, so this would work with the case with 0, 0, 0, right? Yeah, I think so. Let's run this thing. String indices must be integers, not tuple. What? String indices must be integers, not tuple. Oh. Do I do it like this? Python string substring. It's colon, okay. I to I plus 1. Have I done this anywhere else? Probably not. Okay. I return 2 here, 3 here, 0 here. Okay. Well, at least we're getting the 0 case. Okay, time to start printing stuff out. Let's print out what we're actually considering as numbers here. Print maybe SI, and then print I plus 2. Sure. So we're counting 1 and 2 and 12. Oh, that's good. So why are we returning 2? Why? Hello? So why are we returning 2 then? So we say that 1, we're saying that 1 is a valid digit, 2 is a valid digit, 12 is also a valid digit. Should we print this case out to print return 0? We are adding 1 at the right places, aren't we? Single digit plus double digit. And then we're setting double digit here, single digit here. Okay, 1, 2, return 0, 12, return 0. Wait, this should work, no? Why are we... Oh, we're outputting 3. Oh. Our output is too big. Oh, I see. I think I see what's going on. I'm returning the number of digits we can use individually in the given string. We're only supposed to return the number of combinations, the total number of combinations you can make. So that means when we return, when we go out of bounds, we should return 1 instead of 0. Because that means we figured out a way to reach the end. So over here, we should just call the helper function. We shouldn't add the current digit. We aren't trying to count the number of digits in our combinations. We're just trying to see if there's a way to reach the end. And if we reach the end, then that's a valid way to look at the numbers, and then we return 1. Yeah, okay. So really what the helper function represents is, like, how many valid ways are there currently to get to the end? There we go, we did it. Nice, that worked. Okay, I'm gonna add a at cache here. And then let's submit this. No, wrong answer. Expected 1, but the output is 3. Okay, let's use this test case. We're pretty close though. 229 of 269 passed. So apparently there's only one way to interpret this. 2101. Oh. The 0 might be throwing us off here. Okay, I think we should print out what we're printing out here again. Okay. add cache, go. Okay. Yeah, okay, so we're doing 2, 1, 0, 1, return 1. Okay. So apparently we think that 01 is a valid number. Oh no. I think we need to do the first number not equal to 0 again. Yeah. If S1 is equal to 0, there's no way the double digit method would work either. I guess we can put it here. If Si is not equal to 0, whoop. Is a really quick check. Yeah, there we go. Submit. Please, work. We got it, let's go. Alright, that wasn't so bad. Well, I did struggle on it a little bit. But that wasn't too bad. This could be a bit cleaner, no? I'm doing two really similar things here. Are zeros just completely out of bounds here? So if current SS I is the current digit is equal to 0, there's no way we can use it as a single digit. So just return 0, right? Return 0. And now should do this whole shtick here. Yeah, so this can be simplified like this. This is much cleaner. Run this. No. Oh, equals. Nice. And if we run this, this should give us a better percentage too, because I just removed all the print statements. Oh no, it's the same. Oh well, okay. At least we're on the board now. So this should give us... What's the time complexity of this? We definitely need to... I mean, worst case, we branch twice on every single number, right? So if you have like 1, 2, 3, whoop, 3, 4. Let's see what the root here. We can branch like 1, 1, 2, and then here. After this, 2, 2, 3. I guess it's like, is this all of n time? It's like exponentially increasing. No, not all of n. I meant 2 to the power of n. Probably 3, 4. Yeah, probably 2 to the power of n ish time. Okay, let's look at what the fastest people did. What are they doing here? Oh, they even annotated this for us. Nice. 2 choices. Get 1 digit shouldn't be 0. Get 2 digits should be between 10 and 26. Use DFS. Okay. Base cases. Oh, I think they did a similar thing to me actually. If I is equal to length s, return 1. If I is greater than length s, return 0. Oh, never mind, it's kind of different. Result is equal to 0, so if the current digit is between 1 and 9, result dfs 1 plus I plus 1. Oh, that's basically what I did. If the next index is out of bounds and the next two digits are between 10 and 26, return dfs 1 plus 2. DFS. Oh, this is long, what the heck? But basically, if you break it down into a recursive case, it's basically what I did. Top-down dynamic programming. What about bottom-up? Wow, this guy did both. Bottom-up DP. DP lane S is 1 for I in range. Length S minus 1. Oh, they're starting from the end. From the end to 0, going backwards. If Si is equal to 0, dpi is equal to 0. Oh, this is kind of confusing. What would the DP array represent? The number of combinations ending at the current index or starting at the current index? We are starting at the end. So probably starting, right? Starting at the current index. If the current one is 0, then return 0. Okay. Else dpi is equal to dp I plus 1. The next one, if I plus 1 is less than s, meaning it's inbounds, and si, the current one, is on 1 or 2, I tried with DP bottom up approach. Hey, good for you. DP bottom up is always more difficult for me to understand. And Si plus 1 in 0, 1, 2, 3, 4, 5, 6, DPI is plus equals DPI plus 2. I see. Ah, I see. So basically, the number of combinations we can make starting at I, you can always do an I plus 1, meaning you use the current digit and then plus the number of combinations, combinations you can do skipping the current digit after using the current digit. And if you check that you can make a valid number with I and I plus 1, then you also add the number of combinations you can make by skipping 2 here. Sal says, oh, your name is Sai. Submissions / That is a huge number. What does that mean? Check the code. Add to the current URL. Oh, you're giving me a URL. Okay. Hey, it's you. Nice. Oh, what the heck? This looks so... Oh, okay, never mind. There's stuff down below. Okay. So I guess DP for this is... Are you doing what's the number of combinations starting at the current number? If S0 is equal to 0, return 0. Yeah, that's base case. Size of array is equal to n plus 1. 0 and 1 is equal to 1. Oh, interesting. You're starting the other way. For I in range 2, comma n plus 1, one digit is equal to s I minus 1 or s I minus 2. What is this? Oh, you're getting the actual digits. Okay. If one digit is not equal to 0, dpi plus equals dpi minus 1. Oh, interesting. Oh, so your DP is, your DP array represents the number of combinations you can get ending at the current I. dpi minus 1. And then if you see your 2-digit one can be between 10 and 26, dpi plus equals number of combinations I minus 2. I see. I think I'm barely understanding this. But I think I want to draw this out just to make it easier for myself. 1, 2, 3, 4. Okay, so 0, 1. You always start at 2, that's interesting. For I in range, si minus 1. Wait, so your dp 0 and 1 always start at 1 here? Oh wait, you do n plus 1. Oh, is this what you mean then? So like 1, 1. I guess the 1 is used for adding. Okay, so the number of combinations you can make ending at 1 is just 1. That makes sense. So one digit is si minus 1. Wait, I minus 1. Oh, I see. Because you start by 2. So this is index 1. Okay, so you look at 2 and then 23. Yeah, okay, I see. If the digit is not equal to 2, dpi is equal to number of ways ending at 1. So you have 1, else dpi plus equals I minus 2. So 1 plus 1 is 2. Oh, I see. Cool, very cool. Yeah, it's still pretty hard for me to wrap my mind around DP stuff, but I think I'm slowly getting it. And then 3 over here, you look at 3. Okay, I think I understand the general idea. Should we do another problem? Unique paths. Sure, you know what? Let's do another problem. Leave this site. Leave this site. There is a robot on a m by n grid. The robot is initially located at the top left corner, grid 0, 0. The robot tries to move to the bottom right corner. n minus 1, n minus 1. The robot can only move either down or right at any point in time. Given the two integers m and n, return the number of possible unique paths that the robot can take to reach the bottom right corner. The test cases are generated so the answer will be less than or equal to 2 to the 9. Okay. So it can either move down or right. This seems pretty simple, no? Let me get my marker out. So what's the base case? If you reach the end, like, let's say you track your current position with I and comma j, the coordinates of your current position. So 0, 0 will be here, n minus 1, n minus 1 will be here. So if, I'm just going to say at end, if you're at the end square, that means you found one way to reach the end, so return 1. Else, from your current position, you can make two decisions. One is move either down or right, so let's say I is the row, so you can do I plus 1, and then j stays the same, or you can do I and then j plus 1. Yeah, and then your solution is, well, you would return the sum of these two options, right? The number of ways you can get to the end using these two options. Yeah, and then the base case would be, well, what's the base case? If you're out of bounds, yeah, if you're out of bounds, then return 0. So if out of bounds, return 0, because that means you have not found a way to get to the end, or the current way is invalid. I feel like that's it, no? Okay, let's try this. We probably need a helper function. Okay, ikuzo. Let's make a helper function where we have the current I, j. So if I is equal to n minus 1 and j is equal to n minus 1, meaning we're at the end, then you return 1 because we found one way to get to the end. Else, we have to check if we're out of bounds. If I is greater than or equal to m, meaning you overstep your rows, or j is greater than or equal to n, meaning you overstep your columns, return 0. Else you return helper I plus 1 j plus helper I j plus 1. And then in the actual function you return helper starting at 0, 0. And then you will probably cache this at cache. Run this thing. Invalid syntax. I equals n minus 1. Why is this invalid syntax? Did I forget my types? I don't think that's it. Types are optional, right? Oh, j equals. It worked. Let's go. Submit. Please don't get time limit. It worked! Dang, we solved this so fast. That has to be some sort of record time for me. Not in general for Leetcode, but for me. GG, thanks, Sai. Let's see what the smart people are doing. They're probably doing some DP solution. Oh! In record time for sure. For me. So DP I times n. Okay, so they're doing a 2D array for I in range 1 comma m. Man, this is hard to think about. For j in range I comma n. Okay, dp ij is equal to dp I minus 1 j plus. So they're taking the So the current, I'm going to assume the dp, what the meaning of the dp is, what's the maximum amount of ways you can reach the current square. So the max ways to reach the current square is equal to the max ways to reach the how do I say this? The max ways to reach the current square is equal to the max ways to reach the square above me if there is one, plus the max ways to reach the square to the left of me. And then you would return dp n minus 1, n minus 1. I see, okay. I see what they're doing here. I guess that's true. Let's say you're at here, right? Let's say this is your like target over here. This is your n square. Yeah, I guess that makes sense. So let's say there's like, I don't know, 2 ways to reach here and then 3 ways to reach here for whatever reason. The number of ways, because from this square you just need to take 1 step here, right? From this square here you just need to take 1 step. Oh, okay. So literally 2 plus 3. I see. I guess that makes intuitive sense. I don't think of how I would have thought of this in the first place though. Recursion is still more intuitive for me. Okay, sure. And so every square begins with 1, huh? What happens when, for I in range 1, what happens for this one? This is just 1, down here just 1, and this is 2. Oh, I see. Dang, that's kind of trippy to think about, but I can see why it works. Okay, very cool. I think I will save the last recursion problem for tomorrow or Friday. Yeah. Okay, I'm gonna end this question number. Kushagra says question number 62, unique paths. Yeah. So next time we're gonna do jump game. Oh yeah. Let me copy this. Well, you can probably search this up pretty easily too, right? Let me still go to my live. The list? Oh, this list. Yeah, sure. You can just Google blind 75 Leetcode questions. Let me paste this in. How do I go to my live chat here? Oh, like this. There you go. Enjoy. Yeah, okay. I'm gonna end the stream then. Dang, we sure did this problem really fast. Unique paths. I like it. Okay, see y'all Friday, hopefully. I might stream on Friday if I have time. Else, I will see you guys on the weekly contest on Saturday. Bye, Sai. See y'all next time. Oh, hey Fortuner, yo ho. How's it going? Good night, Sai.